This is section 5.1, part A, the idea of probability. Chance is all around us. You and your friend play rock, paper, scissors to determine who gets the last slice of pizza. A coin toss decides which team gets to receive the ball first in a football game. Many adults regularly play the lottery, hoping to win a big jackpot with a few lucky numbers. Others head to casinos or racetracks, hoping that some combination of luck and skill will pay off. The traits that children inherit, such as gender, hair and eye color, blood type, handedness, dimples, whether they can roll their tongue, are determined by chance involved in which genes are passed along by their parents. The mathematics of chance is called probability. Probability is the topic of this chapter. In football, a coin toss helps determine which team gets the ball first. Why do the rules of football require a coin toss? Because tossing a coin seems to be a fair way to decide who gets the ball first. A big fact emerges when we watch coin tosses or the results of random sampling and random assignment closely. Chance behavior is unpredictable in the short run, but has a regular and predictable pattern in the long run. This remarkable fact is the basis for the idea of probability. So when you toss a coin, there's only two possible outcomes, heads or tails. The figure below on the left shows the results of tossing a coin 20 times. For each number of tosses from 1 to 20, we have plotted the probability of those tosses that gave us heads, or the proportion of those tosses that gave us heads. You can see that the proportion of heads starts out at 0 on the first toss, raises to 50% when the second toss gives us a heads, then falls to 0.33, then 0.25, and then 0.2, as we get 3 more tails. After that, the proportion of heads begins to increase, rising well over 50% before it decreases again. Suppose we keep tossing the coin until we've made 500 tosses. The figure to the right shows the results if we have 500 tosses. As we make more and more tosses, the proportion of heads gets closer and closer to 0.5, and it is going to stay there. So this is the proportion out of all of the tosses together out of the 500. The fact that the proportion of heads in many trials eventually closes in on 50% is guaranteed by the law of large numbers. This important result says that if we observe more and more repetitions of any chance process, the proportion of times that a specific outcome occurs approaches a single value. The value that a specific outcome approaches is called the probability. So the probability of any outcome of a chance process is a number between 0 and 1 that describes the proportion of times that the outcome would occur if a very long series of repetitions were completed. Outcomes that never occur have a probability of 0. An outcome that happens on every repetition has a probability of 1. An outcome that happens half of the time in a very long series of trials has a probability of 50%, or 0.5. The mathematics of probability is based on imagining what would happen if an indefinitely long series of trials were completed. So let's check our understanding. According to the Book of Odds, the probability that a randomly selected U.S. adult usually eats breakfast is 0.61. Explain what probability of 0.61 means in this setting. This probability means that if we asked a large sample of U.S. adults whether they usually eat breakfast, about 61% of them would answer yes. Why doesn't this probability say that if 100 U.S. adults were chosen at random, exactly 61 of them usually eat breakfast? In a random sample of 100 adults, we would expect that around 61 of them would usually eat breakfast. However, the exact number will vary from sample to sample. Probability is a measure of how likely an outcome is to occur. Match one of the probabilities that follows with each statement. Be prepared to defend your answer. So our possible answers are 0, 0.01, 0.3, 0.6, 0.99, and 1. So for A, this outcome is impossible. It would never occur. This would be the probability of 0. If it can never occur, that means there is 0 chance, so our answer would be 0. The outcome is certain. It will occur on every trial. If it's going to occur on every single trial, the probability would be 1 or 100. This outcome is very unlikely, but it will occur once in a while in a long sequence of trials. This would be a probability of 0.01. There's only a 1% chance that it's going to happen in a long series of trials, so this makes it very unlikely. This outcome will occur more often than not. So if it happened the same amount that it did not happen, that would be 50%. So more often than not would definitely have to be more than 50%. It's not happening almost every single time, so our best answer would be 0.60. It's happening more than half the time, so it's happening more often than it is not happening.